Hello, I'm Michael Aboud. This is question 19. I have some loose notes written down that I'm kind of riffing off here, so I won't be looking at the camera too much. The question is, please explain the kinetic molecular theory and how it applies to gas molecules. Your answers should include the postulates and an explanation as to which are valid and which are not valid for real gases. So we're talking about the kinetic molecular theory here, how it applies to gas. The kinetic molecular theory, it describes the movement, the behavior of the microscopic values in gases at a particulate level, how they move, where they're positioned. We could use these values to determine the macros, which in this case would be the pressure, the volume, and the temperature. For instance, the movement, the kinetic energy of the particles is actually the same as the temperature in the gas. So sorry if you hear my dog snoring. So let's talk about the postulates of this and which ones do not apply to real gases, which we won't be dealing with in this class, but it's good to know. So the postulates, excuse me, the postulates of the kinetic molecular theory are that the particles, sorry, let me scroll down. Okay, the particles are always in a constant rapid movement. The combined volume of the particles is not real. It's negligible. It doesn't matter. This, however, is not true for real gases. Okay, the particles exert no forces on one another. This is not true in real gases. I believe that there is an actual attraction between the molecules of a real gas. Between the molecules in a real gas, but since we're using the ideal gases here, then we're solid. Another postulate is that any collision between the particles or the container are completely elastic. They are, I'm trying to use the words that you use, or they're inelastic, sorry. And, this basically just means that there's no energy lost. But this is not true for real gases. And then the last postulate, I believe, let me make sure I did them all. Well, of course, there's the postulate that all matter is made up of atoms or molecules. Let's see. Yeah, so then the last one is that the average kinetic energy is proportional to the absolute temperature. And yeah, that would be in kelvins. So, yeah.